Hey folks, I'm going to talk to you about multiplying polynomials by polynomials in this video, and they can be a little bit tricky, so let's follow along. Alright, so I have some examples here. I actually want to start off on the right side first. So I'm going to use the distributive property here and take this A, and I'm going to multiply it to both things on the right, on the set of parentheses on the right. So this is now A times the C plus A times the D. So that's AD there. So we sometimes call that the first and then the outer. Now I'm going to do the inner two terms with that B times C and get BC. And then my last term, which is B times D. Okay, so we call that FOIL. First terms in both set of parentheses, outer terms, inner terms, and then the last term in each set of parentheses. All right, and there's actually no things here, no terms. I can simplify because everything has weird mix-up of letters. Keep in mind, though, usually the stuff in the middle I can combine. Not always true, so double check it, but it is sometimes true. All right, now let's look at the one that's a little bit more complicated over on the left. I'm going to take that 2x, and I'm going to multiply it to both things in the second set of parentheses. So 2x times 4x. And I'm adding that to the 2x times 3y. And then I have the y gets multiplied to both things over there. So now it's y times 4x plus y times 3y. So I have 1, 2, 3, 4 terms. And that should happen because I have 2 terms times 2 terms, which gets me 4 total terms. Now I just need to clean all this stuff up. 2x times 4x, I can multiply my numbers, and I get an 8. And then an x times an x, just like our last one, we know that that gets us x squared. My next chunk, I have 2 numbers that are being multiplied, so that just gets me a 6. And then an x times a y. I can't do anything with that. I can't combine them in any way, so I just put them next to each other. I like to put them alphabetical, but that's up to you. Next one, I have just a 4 there, so I'm going to bring down that 4. And then I have a y times an x. And again, I like to write them alphabetically. Next one, I have a 3, no other numbers. I'm just going to write down that 3. Then a y times a y gets me y squared. Now I actually do have some stuff that I can combine. Remember, I told you on that last chunk, it often happens that way. So 6xy plus 4xy. Their exponents are the same. The number of letters they have, the kind of letters they have are all the same. Awesome. I can combine those two things. So I have 8x squared is not changing. 6xy's plus 4xy's gets me 10xy's. And then nothing with that 3y squared, so it's just going to come down. And that is it. That is distributing those two polynomials together. Let's look at another example. You'll notice this has 3 terms, right? 3 different things separated by pluses or minuses. And they're being multiplied to a thing with 3 terms, which means my first round, I should end up with 9 terms. All right, I'm going to write this one out a little bit differently. So this x gets multiplied to all of that. So x, and then I'm going to put this in parentheses, x plus y plus 5. Literally writing all of that right next to that x. Then let me switch colors. I have this y gets multiplied to all of this, and that's a plus. So I have plus y times all of that. Now I'm going to switch colors again, and I've got this negative 3 times all of that. So I have a negative 3 times x plus y plus 5. Now I'm going to distribute in each one of those. So that x gets distributed to all 3 terms in those parentheses, x times x. Since they're the same base, I add their exponents. I end up with x squared. X times y gets me xy. X times 5 gets me 5x's. Then in blue, I have that y that gets multiplied in. Y times x. Again, I just like to write alphabetical, so I'm going to write xy. Y times y, I add the exponents. Y times 5, I like to write my number first, so I get 5y. Then I have to do the same thing, but in green, and that negative 3. It is a negative 3 that gets distributed in. I'll take all of that negative 3 in, and I get negative 3x's minus 3y's minus 15. Now, we should go through and try and add up any like terms that we have. I have this xy, xy, okay. I'm also going to have, let's see, I have 5x's and negative 3x's. I have y squared. Oh, I don't have any other y squareds, okay. But I do have y's and y's. Okay, so let's combine those things. X squared doesn't have any buddies. And then I have x times y and x times y, both of those. So I now have 2 of them. I have 5x's and negative 3x's. Get me 2x's. So now I've taken care of that, that, and that. And then I have 5y's minus 3y's gets me 2y's. Then I have y squared. And then I have that negative 15. So a lot of things combined, but still a lot of things don't. And where I talked about we had 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Once I've fully distributed, I should have that number of terms, and I do. Awesome. And we have one more example. This one, I'm taking this x squared, and I'm going to distribute it to everything. Let me do the same thing I did last time. I'll do it in orange. That one times all of that. So x squared times x squared minus 5x plus 2. Then I need to go over to, I think I did blue next last time. So a 3x gets distributed to all of that. Then in green, I have that negative 7 that gets distributed to all of that. Very similar to the last one, except there's no y's. All right, then we have to distribute that front term to all 3 of those pieces inside. X squared times x squared gets mixed to the 4th. X squared times negative 5x. Now it's negative 5x cubed because there's a 1 there on that exponent. X squared times 2 is 2x squared. And then I'm going to do the same thing in blue. Plus 3x cubed minus 15x squared plus 6x. Then I have to do the same thing in green. That negative 7, folks. It's a negative 7 that gets distributed in. Negative 7x squared plus, because there's double negatives, 35x's. And that does not cancel out that negative 7 for the next one. It's just between those 2 terms. It's still a negative 7 that goes to that 2 and gets negative 14. Now I have to look for common terms, or like terms, sorry. And there's going to be a lot of them. There's this x cubed and this x cubed. There's this x squared and this x squared and this x squared. And then I have this 6x and that 35x. I like to use different symbols so that helps me figure out what's what. And then that x to the 4th had nothing in common with anybody. Negative 5x cubed plus 3x cubed. I'm going to cross these out as I go too. So negative 5 and positive 3 gives me negative 2x cubes. Okay, so I did that one and that one. Then I have 2x squared and negative 15x squared and a negative 7x squared. So I'm going to do those first 2 things first. Positive 2 and negative 15 gets me a negative 13. And then I'm subtracting 7 more. So it's a negative 20x squared. Did that one, and that one all together. Now I have 6x and 35x. That gets me 41x's. And then I have that negative 14. Has no like terms at all. Whoo, that's a big old thing. And this one doesn't happen to ask you what in particular you need to know about this. I just want you to do it. But I also just want to point out real quick that this is a degree 4 polynomial. And that is because the largest exponent is a 4. My leading coefficient is the number in front of my largest degreed term, which is a 1 out there. So I just want to point that out because that will be important later. Sorry, that's kind of an ugly one. There you go. And That's all, folks. Hopefully this was helpful, and I hope all of you have a great rest of your day.